So we're just taking that out of the fridge, and yes, it has gone quite solid. Let's have a look at that. Oh, one little flat layer of thin chocolate drizzled, and you can see that can be made then into little, well, it's still bendy. It's bendy rather than breaky. I wonder if that's because of the oils we put in it. And there's my initials, BA, which stand up quite nicely and have become solid again. So get to test my initials. And that tastes pretty much the same as a chocolate chip as well. So I would say very little change has occurred other than its shape. We're able to change the shape through changing its state from a solid to a liquid and back to a solid again, but the chocolate tastes the same and is still much the same substance, unless we take it too far and it becomes burnt, and then it doesn't quite end up being tasting the same as before, although that's still pretty good. And I'll just try a bit of this burnt chocolate from here. Quite crunchy, and yeah, a little bit of a burnt taste. Definitely hasn't gone back to being exactly as it was before. So what does that tell you about chemical or physical change with the burnt chocolate? And even the process of burning a match, is that a physical change or is that a chemical change? Definitely there's some gas being produced, because we can see it burning in the flame. It's a flammable gas being produced. And is it reversible? Well, once it goes black like that, it's probably not reversible at all, is it? And has a new substance been formed? Well, I think so. That black char, mostly carbon, is definitely something new to what was there in the wood to start with. So burning something is just about always a chemical change. So don't be surprised if underneath your spoon you find some black carbon there. Don't worry too much about it. It will wash off with a steel wool or a scourer in the wash.